have to save them as one thing. So if you take one scan and you fix it, then you just do the same thing, and it looks like when you do it, you'll see that it looks like it's dropping the second page right on top of the first page, and that's creating 2 pages. And that's why I'm having people try it, just to see if they can get it to work. So if they don't know how to do it, then I can help you. And then you got to be able to kind of figure out, well, where is it? I think my easiest thing is I created before the test, I think I would create in your Google Drive, I think I'd create a folder that says, AP exam. And on the actual day of the AP exam, that's where you place your works, or however you need to submit it, because you need to on the ticket however you get this ticket from AP and it shows your thing. One of the things that's going to happen is you're going to have an opportunity to either submit a text file or to submit photos, and that's why I would go and do that practice demo that's on Schoology that I put on there, and you could submit one text file that has multiple pages, so one PDF, or you can submit multiple pictures if you do pictures. So that's your choices. Either and again, hopefully I'll either do it today or tomorrow, and I'll kind of walk through, and I'll go through a practice round and show you what I mean, and then I will. And maybe I can do it on my phone. Maybe I can try to do it on my phone. It's hard to record what I'm doing on my phone, but I know I can do it. I can record my screen. So I'll try to do that. But that's what we're trying to do, is just try to practice that. Anybody have any other general questions before I do yesterday's problem?
Okay, I'm going to leave.
You're going to leave?
Because I'm going to do yesterday's problem.
Fine. Then leave.
Okay, just
good luck.
Wanted to let you know. Thank you.
Okay, thanks.
Actually, wait, are we going to get another one tomorrow?
Yeah, they're already in there. I actually put 2 in there, and it wasn't because I'm trying to kill you. I'm just trying to get you all the things. So I actually put 1 in for tomorrow and for Saturday, but I promise you.
Saturday?
I promise you, well, I can't put Saturday, so I put 2 in for Friday. But I promise all of you, and I sent it in the email today, that I will not be giving you work for at least a week after the exam. I won't give you a single thing. You might not even hear from me, unless you want to. But I will not be giving you work for at least a week. So although I'm giving you tons of stuff right now, I'm not going to give you work after. I'm not going to give you work for at least a week after the exam.
Okay.
Because I know I'm killing you right now. So, okay.
Bye.
All right. Bye. All right. Can you guys see? This is the problem you guys did yesterday, right? Maddie, give me a thumbs up because I can see you on the camera. Is that it? Yes. Okay. So this went really well. I mean, for a lot of you, this went better than the previous one. There's a couple things that that I saw that I noticed people did. Some people are still simplifying, and I can't express enough to don't simplify. But I think things went much better on this. So let's just look at part A. Or the whole problem, just the stem of the problem. You look at it, and one of the things that I would kind of highlight right out of the gate is that this K of T is in feet per second. That means if we integrate it, if you think about the steps, that it's in feet per second. So if you go down and you integrate, this should be in feet. And if you differentiate, that would be in feet per second per second. That's an important piece to know because this is what you're given. You're given this piece right there. So that's where I would, think about the steps, because if you look at part A, we're differentiating, which means our unit of measure, when they say indicate units of measure here and indicate units of measure here, you should already know what the unit of measure is. Unit of measure for part A is feet per second per second. The unit of measure for part B, because we're integrating, is just going to be feet. And they asked for it in both of those. So that was worth 1 point, was having units in parts A and B. And you had to have it in both. So with part A, they asked you on here to do Kathleen's acceleration at time t equals 4. And 4 kind of comes right in this area right here in that little box. So that's all you have to do. So literally when you're answering this question, you should have just done 10 minus 5 divided by 5 minus 3. And you could have instead of leaving this as kind of a bald thing, you could have said that this is k prime of 4, and it's really not equal to, so it's approximately equal to this. And then again, it would be in feet per second per second.
You still will get the point if you have the units, but you don't have like the k prime of 4, right?
Yeah, if you had this, that would be correct.
Okay.
This is kind of maybe the one time that they don't call that a bald answer. They say that that's a good result. Now, I do worry about students that simplify this to 5 halves, because I think it's really important to show how you got the conclusion of the 10 minus 5 and the 5 minus 3. So I would encourage you, please don't simplify. Please don't simplify at all. Just leave it like that. Now, that was really, that was just worth 1 point. The units for part A and B together was worth another point. So there was 1 point for units in A and B. So together you had to have it. So you had to have feet in part B, and you had feet per second in part A, and that's how you would have gotten that point. Any questions on part A? Okay, so for part B, it says use a right Riemann sum. So that's an important piece. And it says with 4 subintervals, and it's indicated by the table. So that's the thing that you're going to do. And then we'll talk about the second part of this, but let's just do that part first. So if we just do that part, the 4 subintervals would be, this is one interval, this is another interval, that's a third interval, and that's the fourth interval. So some of you did really even a better job than my answer key did. Some of you kind of said, okay, well, my first interval is from 3 to 0. And if I use the right-hand side, notice I'd be using this 5 here, then plus, and then if I do 5 minus 3, and I use the right-hand side, I'd be using the 10, then plus, and then if I did 8 minus 5, the right-hand side would be 20, and the last one would be 12 minus 8, and the right-hand side is 24. And then that's in feet. Again, you don't have to simplify it. Please don't simplify it. Leave it just like that. I know that it simplifies. I know it simplifies down to, actually, I don't even remember what it was, maybe 119 if I remember people that did simplify it. But don't, because you could run into a problem. You could run into a place where you did this great work and somehow instead of putting, for that first 3 minus 0, instead of typing that into your calculator, you hit a 2 instead of a 3. And now you'll get it wrong. And now it's wrong, and you didn't need to do it. And if you had just left it the way it was, if you had just left it the way it's written right there, you'd get it right, and you'd be good. Any questions on that? Okay, so the next part is, it says, is this approximation an overestimate or an underestimate? Explain your reasoning. This came from the notes on the Riemann sum. If you look back at the Riemann sum notes, you'll see that I kind of addressed this at that time. So go back and look at those notes on the Riemann sum. Because what you'll find out is, because this is an increasing function, because k is an increasing function, that what happens is you generate a graph that looks like this, and when you use the right-hand side, the rectangles go outside of it. So it's an overestimation. So if I were going to do this, I would say overestimation. And the reason is because k is increasing. That's the reason. K is increasing. That's the reason it's an overestimation, because k is increasing. And it comes from the fact that that's what it looks like. You know, if k is a decreasing function, then that right Riemann sum is an underestimation. If we had used a left Riemann sum, then we would have had an underestimation with this particular function. But because we're using a right Riemann sum, and it's an increasing function, you know that this integral is going to be an overestimation. Any questions on that? That's one of those pieces of notes that you want to have next to you, and it's really why I kind of covered that last week, because I said, boy, you really just have to have that so that you you don't have to necessarily have that memorized. You just have to have it somewhere where you can recall it. You maybe already do have it memorized because you've written it down enough.
Wait,
Yep.
So if we were using a left Riemann sum, k would be decreasing?
No, k is increasing either way. That was at the beginning up here, up in the stem of the problem. If you see Kathleen's velocity is increasing. But if it were a left Riemann sum, then if it were an increasing function and it were a left Riemann sum, then notice that the left-hand sides would make it an underestimation. You see how I drew that?
Yeah.
So then if it's a left Riemann sum, it's an underestimation if it's an increasing function. So if I were to summarize this, I'll do it down here. If it's an increasing function, the right Riemann sum is an overestimation. The left Riemann sum is an underestimation. Okay? If it's a decreasing function, that flip-flops. The right one is an underestimation, and the left one is an overestimation. So that's what happens. That's really kind of the summary. And if you remember back from the notes, I had said that we don't really make these determinations on a trapezoidal rule, because the trapezoidal rule would use whether or not the function was concave up or concave down. Because if you think about like what a trapezoidal, for the trapezoidal rule, you think about what that looks like, the trapezoids would look like that, right? So if it's a concave up function, then the trapezoidal rule is an overestimation. But for the trapezoidal rule, if it's concave down, and we draw a trapezoid in there, then the trapezoidal rule is an underestimation. So that's I haven't really have I never seen it. I don't know if I've ever seen it asked with a trapezoidal rule. Because usually they would have to, it would be more difficult to describe it in the stem of the problem the way they did right here. It'd be really difficult for them to describe that in the stem of the problem because they'd have to talk about the second derivative being positive or negative, and it would be much more difficult, I think. So I don't think that they would ask that for that kind of question for a trapezoidal one. Any questions now? Okay, so then let's talk about this next one. Although some people did write an equation, I want to kind of cover that. So Nathan's velocity, I'll highlight some things in orange here. Nathan's velocity is given by this. Again, if you think about that being velocity, that's that middle step in the step diagram. So now, if we wanted to go down to distance, we would need to integrate. So that's the first thing. The next thing is when they say integral expression, that doesn't necessarily mean you have to write an equation. Some people did, and that was fine. Couple things in here is Nathan started 5 feet at time t equals 0, and we're supposed to figure out where he is at 12 seconds. So one of the things I would have done on this, and the way I was really minimal in my answer. Notice they give me Nathan's velocity in feet per second. So what I'm going to write is I'm going to write part C as the 5 feet that we started ahead of everything, plus the integral from time t equals 0 to time t equals 12. And then we would need Nathan's velocity in here. If you put the absolute value bars, that would have been fine. You wouldn't have been penalized. You wouldn't have been more right. I think it's always good to write a dt to close the, that kind of closes the integral, because I saw some problems that I saw where I saw people do this. That's wrong, because we would, as AP readers, we would write the dt right here, and now that's not right. Now we're not handling that initial condition the right way. So in general, I wouldn't write it this way. It's why I've never really ever explained, or I've never really put that 5, that initial starting value, ahead of the integral. I've always put it, I mean, I've never put it behind the integral. I've always put it in front of the integral. It would have been okay if you had written the integral from 0 to 12 of n of t dt plus 5. That would have been okay. Now, that's a subtle difference, but that's okay. But this one you don't want to do. It's fine if on this problem you had done 5 plus the integral from 0 to 12 and you put in this 150 over t plus 3 minus 50 e to the negative t. That would have been okay. My biggest concern on that is you're writing a lot of stuff in there. If you don't write 150 and you accidentally write 15, now it's wrong. If I saw people write -1 in for t because maybe they didn't read it, that it was a t in there, and maybe that's on me that it was hard to read. My biggest advice to you is if they define it as n of t, use it as n of t in that integral. Use that down there because it's easy. They know what n of t is. It's defined that way. So just use it that way, and then you'll be in a much better place. Does that make sense? Does anybody have any questions on that?
So I wrote it like with the equation, and then I put 12 in for t because it was at 12 seconds. Would that be wrong?
Yes. The reason it would be wrong is the 12 seconds is the velocity at 12. And so it's not generic enough. I mean, I saw that, Maddie, and I thought that was just one little unfortunate error. And so you really want to put that expression in there. And that's why I think going over this, you wouldn't make that mistake next time now that you've seen this.
So you just wouldn't put the number in for t.
No, because remember what we would do on this integral is we would integrate it, and then we would put in the top bound minus the lower bound, and so we would eventually put in the 12, but only after we've integrated it.
Oh, okay.
Is when we would do that. Yeah. Any other questions? Okay, so then the last part is part D, and I'm going to scroll out a little bit just to, so the next part it says, and let me pick a new, I'll do it. I don't think I've used blue yet for highlighting. I don't think so. Oh yeah, I have. So I'll do it in silver. So now it's asking for Nathan's acceleration. So again, now if we go back to the step diagram, we're given Nathan's velocity. So if we're asked for Nathan's accelerations, we're going to differentiate this. There's a couple different ways to differentiate it. I think I probably would have used, I'll show you both ways, actually. I'll just do both ways. So I'm going to go down here and I'm going to recopy Nathan's. So Nathan's velocity is equal to 150 divided by t plus 3 minus 50 e to the negative t. So I'm going to differentiate this. First thing I'm going to do is I'm going to differentiate it exactly the way it is in there. So I'm going to erase this stuff. So I can have some room to write here. Okay, so I'm just going to differentiate one time, just doing exactly the way it's written. And so I'm going to use the quotient rule on the first one. And again, we've talked about not simplifying. Don't simplify this either, because it's just saying, you go back to the problem, it just says write an expression. So if we do the low, d high, because the derivative of 150 is 0, minus the top function times the derivative of the bottom function divided by the bottom function squared, so that's the derivative of the first part, minus the 50 comes along, that's the friend that we just have to take with us either way, e to the negative t times negative 1. There's simplification we can do on this, but we don't have to. We don't have to simplify anything. We don't want to simplify it. There's a lot of stuff that we could do wrong simplifying it. The other method you could potentially have used is if you had kind of said n of t is really also 150 times t plus 3 to the negative 1 minus 50 e to the negative t. That would have been okay, because then you could have differentiated this, but instead of using the quotient rule on the first one, you would have just left the 150 there, dropped the power down, reduced the power by 1, and then the second part would differentiate into the same thing it did originally, and those are actually this, either one of this answer or this answer was acceptable. Any simplified version is acceptable as well, but I'm just encouraging you guys not to simplify it, because if you simplify it and you do it incorrectly, it's just unfortunate, and it kind of breaks my heart when I see students do that when I'm grading the exams, because I think that they've done really great work and they've sort of talked themselves out of the answer. Any questions on that?
I also I wrote the derivative correctly, but I also left it as a bald answer. Would I still get points for that or no?
No, you get credit for that one again. Yeah, really good question, Maddie. For derivatives, it's kind of the only time they kind of let it be a bald answer. So if I had not written n of t on here, if I had written it like that, I would have gotten credit for it. Okay, so it's kind of the only time. Integrals generally are the ones that they really don't want to be bald. But if you notice, like the stuff I still have on there, it shows a lot of really good thought and good work. And even if I go back up to part A that we were talking about before, that 10 minus 5 divided by 5 minus 3 is still showing a lot of really good thought and work. So technically, it's not bald in those cases. It shows your methodology behind how did you even come up with those values. I just end up just attaching things to it, but like naming this right here as n prime of t, but you wouldn't have to on that. Good questions. Anybody else have any questions that I can help you with? Okay, I know that today's problem is significantly more difficult. I recognize that. Tomorrow's is a little bit of a longer variety. I pulled it from the practice questions that AP posted, and then I put 2 on there yesterday, one more that AP had recommended students look at before they take the exam, and it's really pretty similar to the one we did on Tuesday, actually. So it kind of gives you another opportunity to check some of your work from Tuesday and some of the other work that we did. I don't know if I'll do more, but I would love to know if if you don't want office hours on Saturday, would it be helpful for me to create videos for answer keys on these two problems that you get tomorrow. Would that be helpful?
Is office hours an option? Like, would you be willing to do office hours?
If it would be something that you guys would be willing, if you guys would want, I think that I can make that happen. Yes.
Okay, because I would want it, because then like you can like ask questions and stuff.
Absolutely. I don't know that I'd want to do it at 1:30. I may want to do it more in the morning,
Yeah.
but I don't know what time is too early for you guys.
I think like 9 in the morning or like 9:30. Everybody should be awake by then.
Okay.
Hopefully.
Anybody else want to vote on that?
Yeah,
I guess-
9:30 is fine.
Okay. So I will, I'll make a note of that. And I do want to help you. I mean, I want to be available to you as much as I possibly can, especially because I'm the one putting all this work on you. If I'll talk to my wife, because obviously I got to check in with her and see if we got something going on Saturday. Even if you can't, even if you miss office hours and you just want the explanation, I've just recorded these office hours too, so I will post a video of what we discuss, and then who knows, maybe if time permits, I'll do 2 office hours on Saturday if that's helpful, because I just want you guys to have opportunities to ask questions. Okay. I will put the answer keys to Fridays probably in Friday's folder, but I'll try to send an email out for that, because I just want you guys to have a place to look for it. So I got nothing else unless you guys have something specific you want to talk about. Okay. I'm going to stop the recording at least.